yellow, 6 green, 9 blue, and 5 red cards in a stack of cards turned face down. Once a card is selected, it is not replaced. So what kind of events are these if you're not replacing the first card? If you're not replacing the first card, they must be dependent events, because that first card, whatever you selected, affects both the favorable outcomes and the possible outcomes for the next draw of the cards. And so we need to keep that in mind when we're calculating our probabilities here. The first problem is asking us for the probability of 2 green cards. So probability of green will be equal to the probability of green multiplied by the probability of green after green. The probability of green, the first green card would be 6 because all the cards are there at the moment. There are 6 green cards out of a total of 25 plus 5, 30 cards altogether. When we find the probability of green after green, we have to keep in mind that one of these green cards is no longer there. So I no longer have 6 favorable outcomes. I now have 5 favorable outcomes. And I no longer have 30 possible outcomes because that first green card was not put back in the stack. So I have 29 possible outcomes. This 6/30ths simplifies to a fifth. And then I see, so we factored out 6/6, which is 1 whole. I have another common factor of 5 here, so I can factor out 5/5, which is another 1 whole. And that leaves us with our final answer, which is 1/29. The next one is asking us for the probability of 2 cards that are not blue. The probability of selecting a card that is not blue is the complement of the probability of selecting a blue card. There are 9 blue cards out of 30, so there must be 21 that are not blue out of 30. When that non-blue card is drawn, it's no longer available, so it's no longer one of the 21 favorable outcomes. Now I have 20 favorable outcomes out of 29 possible outcomes. I see this 20 and 30 have a common factor of 10, so I'm going to divide them both by 10, factor out the 10/10ths, which is 1 whole. The 21 and the 3 have a common factor of 3, so this can become 7/1. 7 multiplied by 2 is 14. 1 multiplied by 29 is 29. So that probability is 14/29. Problem number 14. Your ticket was drawn for Friday's prize drawing. Congratulations, you won a prize. If the probability that you will like your prize is 13/16, what is the probability that you will not like your prize? This is just testing your understanding of complementary events. If the probability that you will like your prize is 13/16, the probability that you will not like your prize must be 1 minus 13/16, or 16/16 minus 13/16. So 3/16. These two probabilities must add up to 1 whole, because you're either going to like the prize or not like the prize. There's a 100% probability that you will either like the prize or not like the prize. Problem number 15 asks for the probability of blue or prime. Now, this is not like the other problems where we were doing probability. If I said probability of blue comma prime, that's indicating two events, one occurring after the other, and we need them both to happen. And then we find the product of those two probabilities. This says this is a simple event. I want the probability of spinning the spinner and landing on a space that's blue or prime. And so this is a compound event. The probability of blue again, blue or prime, is equal to the probability of blue plus the probability of prime minus the probability of blue and prime. I'll show this on a Venn diagram over here too in a minute. But first, let's just calculate these. the probability of landing on blue. Don't be fooled by the fact that there's a 12 here. That doesn't mean there are 12 spaces. You have to check there are 1, 2, 3, 4, 5, 6, 7, 8 spaces. And 3 of them are blue, so that's 3/8. There's a 3/8 chance that I'll land on a blue section. The probability that I'll land on a prime section will be, let me get something I can mark this with. It's probably best. Let's circle the prime numbers. 2 is prime, 3 is prime, 5 is prime, and 11 is prime. Prime number has 2 factors, 1 in itself. 12 has extra factors, 2, 3, 4, 6. 10 has 2 and 5. 9 has 3, and 8 has 2 and 4. So I have 4 prime factors out of 8 possible places to land. So there's a 4/8 chance that a 4/8 probability of landing on a prime section. But I have to subtract the sections that are both blue and prime. The 12 is not, the 10 is not, but the 5 is. So I subtract 1/8 from that. And that gives me 7/8 minus 1/8 is 6/8, so 3/4. I just want to do a little bit of Venn diagram work in case this is unclear. These would be the blue sections, these would be the prime sections. The blue sections are 12, 10, and 5. The prime sections I've circled here. The 5 is common to both, so the 5 goes in the intersection. And so all the favorable outcomes are listed in this. When it says or, it's talking about the union of this Venn diagram. It's this or that. So 10 is blue or prime, 2 is blue or prime, 5 is blue and prime, but it's also blue or prime. So anything in here, so there are 1, 2, 3, 4, 5, 6 favorable outcomes out of a total of 8 possible outcomes. So that's another way to get to this 6/8. And it's also explaining why we want to subtract this 1/8, because otherwise we'd be counting it twice. We count it when we calculate the favorable outcomes for blue and for prime, so we need to subtract it to offset that double counting. The last problem, problem number 16, we're doing just a straightforward calculation using the combination formula. Combination of n items taken r at a time is equal to n factorial over the difference of n and r factorial multiplied by r factorial. So in this case, n is 15, r is 5. So we have 15 factorial divided by 15 minus 5 factorial multiplied by 5 factorial, which is 15 factorial over 10 factorial, 5 factorial. Expanding this, I'm going to have 15 multiplied by 14 multiplied by 13 multiplied by 12 multiplied by 11 multiplied by 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, but I'm not going to show that because that's equivalent to 10 factorial. I know I'm going to be able to cancel it with the 1 in the denominator, so I'll just write 10 factorial here. In my denominator, I have 10 factorial. I know that's going to cancel, so I don't need to expand that, but I must expand this 5 factorial. 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Now canceling the 10 factorials, that's factoring out one whole. Recognize that 4 times 3 is 12, so I could factor out 12 twelfths by crossing off all of these. I have a 5 and a 2, but no 10 up here, so I'm going to do them one at a time. I'll factor out 5 fifths by recognizing that 15 and 5 have a common factor of 5. And I'll factor out 2 halves by recognizing that 2 and 14 have a common factor of 2. I'm left with 3 multiplied by 7 multiplied by 13 multiplied by 11. 3 times 7 is 21. 21 times 13 is 210 plus 63. 273 multiplied by 11. You could do this on a calculator. These are not too hard to compute mentally. 273 times 11 is 273 times 10 is 2730 plus another 273 So that's 29. No, because the 30 and the 70 will be another 100. So actually 3,003. 270 and 730 is exactly 1,000. So I have 1,000 plus this 2,000 is 3,000 and 3 extra after that. So 3,003 is the correct answer for that. Okay, I hope that helped you study for review. It's the final unit test of the year. After this, we're going to work on base number systems for a little while because it's fun, and then start to prepare for our final, or you'll already be preparing at that point, but we'll do the in-class review for the final.